The purpose of this video is to talk about continuity at a point. So f of x is either continuous or not continuous at a point. It's one or the other. Okay, so three conditions must be met for f of x to be continuous at x equals a. So a picture of what's going on here is a little bit easier. Here we have the x-axis and the y-axis, and somewhere along the way there's going to be an a. A represents just any real number along the x-axis. And if f of a exists, it means that when you have an input of a, then there is an output, and the output is some value of y. And so f of a exists. Well, that's fine. And then the limit of f of x as x approaches a, that also has to exist. So we could have that same a, and we could have a limit existing without the value of the function existing, or the function existing at that a. And so that would look like that. So the limit exists, there's a hole in the graph. But for the function to actually be continuous at that value a, we know that the limit has to actually equal the value of the function at a. That's a bad a right there. That's a better a. So when we have the function existing and the limit existing and they equal each other, we say that f of x is continuous at x equals a. So these are the three conditions that must be met. On the worksheet that you guys are going to be doing for either classwork or homework, it'll say the three hurdle tests. So hurdle number 1, 2, and 3 we can see right here. Okay, so that's it. That's the background, and all you have to do is figure out which one, all three are met, or which one does not, which condition is not met, for you to be able to figure out why f of x would not be continuous at a particular value x equals a. So here's another problem. I challenge you to try this one on your own, and then go ahead and play the video and see if we get the same answer. Here we have a function, piecewise function, and hopefully by now you're able to graph these pretty easily. These problems are definitely easier to solve if you graph the piecewise function, and I'm going to go ahead and do that. However, I don't have to, and I would like you to try to do this without actually having to draw the graph. But if you do have to resort to drawing the graph, here we go. We've got x is equal to positive, when x is equal to 2, 1, 2 there, then the value of the function x squared minus 3 is actually 1. So 2 squared minus 3 is 1. So we have, let me draw that in a different color. We know that the function x squared minus 3 is a parabola. It comes down here and goes right up there. And let's see. We know that right down here the y-intercept is negative 3, x squared minus 3. So that's the first piece of the piecewise function. And then we see that the second piece of the piecewise function, the value of the function is just 2 when x is greater than 2. So if we put a 2 right up here, let me draw that in the same color, 2 right up here, then when x is greater than 2, the value of the function is 2. So we can clearly see that the function is only discontinuous at 2, or you could say it as the function is continuous for all real numbers except for 2, but then the question then is why? Why is this function not continuous at 2? Well, we can see, go through the checklist. F of 2 exists. Okay, so f of 2 exists. F of 2 is equal to 1. Okay, and then the second condition, the limit has to exist. Well, we can clearly see that we have a jump discontinuity and the limit does not exist. So the limit as x approaches 2 from the right and from the left do not equal each other. So therefore we say the limit does not exist. We don't need to go to the third condition because we already just this function is not continuous at 2 because it didn't pass that second condition. Limit doesn't exist. So in answer to the question, is f of x continuous? No, not for the entire all real numbers. If not, state the x value. So the x value would be at x equals 2. X value on which it is discontinuous. It's discontinuous at 2. There you go. Let's see, what else do we want to do? That's really about it. What I'd like you to do is I'd like you to try, and I'll put this on the website, so try a couple of the problems on homework 3 before you come to class. Write down any questions that you might have, and I will see you in class.